right. Well, we'll just take these first slides real slow and let people join as they go. So first of all, very excited to be here. I think the discussions today have been just awesome, really insightful. It's great that the building industry and AIA 2030's hosted this great event and brought a lot of people together in a strange time online. But all in all, I think really really powerful to bring people together in this platform, and I'm excited to have the opportunity to share this tool with many others, and hopefully you learn something here today and can share it with your firms, and all come away with understanding a little bit more about embodied carbon. So as we get going, I'm going to drop just a link in the chat to the tool. That's probably the most important thing of this whole presentation, is that everyone comes away with the ability to get this plugin. And as we get going, just to make sure everyone's in the right room, this is the Beacon demo tool. So this is a Revit plugin developed by Thornton Tomasetti to really put power in the hands of engineers to assess quickly and easily the embodied carbon associated with structures. So hopefully that's a presentation that you're hoping to be in. My name's Luke. I'm in the Los Angeles office of Thornton Tomasetti. Also pretty involved with SE 2050 and the local Carbon Leadership Forum hub here. So quick shout out to that. Hope you follow both se2050.org and sign up for email updates, as well as the Carbon Leadership Forum. Great groups. And today I'll be telling you a little bit about Beacon, which is the embodied carbon takeoff tool developed by Thornton Tomasetti's R&D group, the Core Studio. This tool is all open source at the Git book provided in the chat. So as we get started, I just wanted to kind of take a step back to the beginning of the day. I know there's been a lot of information shared, a lot of useful presentations and discussions, and really at the root of this whole conference is this idea that we need to stay on budget, right? Everyone's used to having budgets on their projects, mostly associated with costs. Now we really have to think about our planet and staying on budget to stay within this 1.5 degrees C target set by the Paris Climate Agreement. So that should be in the back of all of our minds throughout this whole process. And really right now in California, it hits home as we're coming off of the hottest weekend in over 100,000 years, something like that. It's really staggering, and it hits close to home when you look outside and the sky is orange with smoke. So I think it just really strikes the importance of our industry to pay attention to this. And here we are. I'm sure everyone's seen this pie chart, but looking at the impact buildings have to that carbon budget. And programs like AIA 2030 have done a really great job of optimizing or educating our designers about building operational carbon. And now, rightly so, there's a lot more attention being paid to the materials and what goes into our buildings. So as a structural engineer, that's kind of the call to action, I think, for me, is really thinking about that embodied carbon piece, and that's what this tool is all about. So here's a chart that a visual that I really like that shows kind of the increased importance or increased piece of that pie of embodied carbon as our buildings get more operational efficient. And then on the right, the importance of measuring that embodied carbon. And Chris O'Hara, I think you're on the call right now. You spoke earlier today on something that really struck home, which is, you can't manage what you don't measure. And that's exactly what we're talking about here. We look at this this research done by the CLF, and we see a wide variety of projects that you know, just the spread of embodied carbon is really hits you. And I think there's a couple takeaways from that. There's, you know, maybe we're not very good at measuring it because we don't have quite the background or the education. So that's one piece that we really need to improve. And B, maybe a bit of speculation here, but it's if it's not measured, we're not paying attention to it. So it maybe just falls on a greater variability. So I think this chart really shows the potential that we have to improve our systems by measuring it and by thinking about it. And that's where Beacon comes in. So Beacon, like I said, it's a Revit tool. It's an add-in, open source, totally free to use. You can download and adapt the source code if that's something of interest. It's all online and not something at all that's like, it's not a paid tool. Thornton Tomasetti isn't looking to, you know, make money or get famous from it. It's simply a tool that I think a need was seen where, you know, we didn't have something for structural engineers or architects or contractors, anyone trying to estimate the embodied carbon in the superstructure to quickly, easily, for free, plug and play. So that's where this tool was developed. And before we get into the demo, I think it's important to step back and talk about Lca and Scope. And there's a lot to learn with this, right? You look at this, it's a pretty common chart, and every box has its own challenges, right? And best practice is to consider the whole life cycle analysis, but it can be challenging, you know? We don't always know what is going to happen at the end of life. So one piece that Beacon, I think is just important at the onset to talk about because it has a significant impact on your study is Beacon looks at the product stage, so cradle to gate. This is similar to EC3 that looks at, you know, EPDs. It's really taking those EPDs and applying them to material quantities. So again, Beacon A1 through A3, looking at what does it take to make the material that I specify. And then I have a dashed line around both transportation and construction, as you can adapt the tool to also include these phases, which I think is important. So here's a little more diagrammatic. Beacon, it's as simple as multiplying material quantities with GWP numbers. And when we say GWP numbers, I think, you know, there's a lot of jargon that goes on: global warming potential, embodied carbon, carbon equivalent, all kind of we're talking about the same sort of thing. So these GWP numbers come from an EPD. Again, lots of acronyms. EPD, Environmental Product Declaration. These are third-party sourced, independently verified. How much carbon does it take to create said product? So Beacon has a lot of these industry average EPDs baked into the program. It allows you to select from a list of materials and multiply material quantity by that GWP number. So very simple and also powerful because you can take more specific EPDs if that information is available and plug that into the tool as well. I found it really powerful to use in parallel with EC3, which has a much more robust EPD database and can get more granular on looking at, say, if I want to look at a concrete mix local to Los Angeles. And why is this important? So without this tool, it's hard to really get a sense of what a good GWP number is, what a bad GWP number is, even if you compare concrete versus steel versus timber. These are all very not intuitive, and that's entirely because material and GWP, you need that the material quantity multiplied by that GWP number to get a useful takeoff, embodied carbon takeoff. So until you do the calculations and run the numbers, really looking just at GWP doesn't tell you a whole lot. So that's what Beacon does. It simply takes material takeoffs from your Revit model, multiplies by GWP factors, and gives you accumulated sum of your embodied carbon. And any questions so far? Again, I'm going to plug in the link to the Git book. You can download this here, and I'm going to run through just sort of high level what the tool does, and then I'll go into a live demo, and we'll also have some time to have some Q&A afterwards. So this is the graphical user interface. Beacon, again, very simple. On the left, you can see takeoff by material, so it's broken down on steel, concrete, timber, unknown, which I'll talk about a bit, and rebar. And then all in all, it's visualized. There's a breakdown either by structural elements, so framing, which is your beams, columns, floors, walls, or foundations. And then you have an overall takeoff, total embodied carbon by material. So you can also visualize this by level. Again, there's some built-in kind of QA tools or structural intelligence, if you will, baked into the program. Here's another kind of QA troubleshooting, which is, say you have a material that isn't concrete, it isn't timber, it isn't steel. It's not something that Beacon is familiar with, so it dumps it into this unknown tab. So you can easily see if you're missing, say your foundation is a mass instead of modeled from concrete. You can find that here, and you can either assign the appropriate GWP factor, or you can change the family in Revit. You can also you estimate rebar using rebar rates. You can filter based on new and existing, or you can map different slabs, or excuse me, different Revit levels to the same level. So this is an example of calling two different levels the roof. Another example might be for steel buildings, you have a top of slab, top of steel. You may want to lump those together. You can do that here, and Beacon will remember your mapping. And we talked a little bit earlier about the CLF benchmark study. This tool links to that benchmark study and will give you kind of a quick assessment of red, yellow, green, how is my building doing compared to that benchmark study. Pretty robust program. You can double click on any of these families from Revit and see just all of the elements in your model that are associated with that family. Really good for troubleshooting. And then you can also export the takeoff, and if you want to do any backend or any other bespoke calculations. So with that, I'm going to check real quick if there are any Q&A questions, and then I'm going to transition to the very exciting live demo. Are there any questions as I get transitioned here? Hopefully this is making sense for folks. Give it one more second. And here we are in a Revit model. So seeing a lot of people working in Revit. Really, it's a good way to have kind of built-in metadata, and that's what Beacon really employs, is the material properties associated with your model. So let's see. As we get going, again, very simple. Under the add-ins tab, there is embodied carbon, Beacon. One click right here. And here's the GUI we saw a bit earlier. I can look at phases, or I can look at mapping levels. This is all new building, and we don't need to look at mapping levels right now. We'll just keep it really simple, and we'll hit run. And just like that, very fast, Beacon gives us a takeoff. Sorry, I got to move some stuff around. Hopefully you can see. Here we go. So on the right, you can see a total embodied carbon normalized per square meter. So this allows you to kind of compare different buildings, or you can compare to a benchmark. You can visually see which elements are contributing the most to my embodied carbon in this case, which is common floors are often the most carbon intensive because the most materials in your floors, especially for this kind of flat plate, or not flat plate, excuse me, for this concrete construction. You can see columns and beams. Foundation is pretty significant. And you'll notice in this first round, we have a problem. We have an unknown material, a wall that's made of carpet. So that's not right. Maybe I had some really terrible handwriting and my modeler assigned a carpet value for the material. Anyways, this can't be read by Beacon. So you can look, double click it, and see all of the locations where this carpet material is showing up. You can go back to your model and find, okay, I'm looking for concrete wall that's 10 inches. You're red. I should have known that you are not concrete. I go back into the material properties that are stored with my model. This metadata can update that, troubleshoots. Now I have concrete walls. I go back to my Beacon tool. Maybe in this case, we map the two roof levels and we call them a roof, and just, maybe I don't want to see that separately. And then I hit OK. Here we are again very quick. Now I no longer have unknown elements. I can focus on what matters. It's a concrete building. As you can see, majority of the embodied carbon is with concrete, from concrete material. And if we look at our floors here, we can see the largest volume is coming from this floor. I can double click and see all the locations in my model where this occurs. I can also play around with the material that this is made of. So again, this is stock full of industry average EPD values. So right now it's 5,000 with 40% fly ash because I was playing with it in the last presentation. But I can change that, automatically pull the new value. Say if I can get away with 4,000 PSI concrete, it can reduce my GWP value. That gets updated automatically, and I get a new takeoff here. And again, pretty quick, I can do that for a number of these other elements. And this is stored. So last time I ran it, I changed this from the default, and it saved what I had plugged in before. So pretty quick, robust. And if I have more information, I can add my own GWP factor here. So in the past, I found it useful to use this in parallel with EC3. So I'm sure a lot of folks are familiar with this tool. I'll drop it in the chat as well. But say I want to look more specifically at California, and I have a range of California EPDs for concrete for my 4,000 PSI concrete. I can more accurately estimate this value. I can plug it back into my my Beacon takeoff. One thing to note is this is kilograms per yard cubed. I do believe this is kilograms per meter cubed. So units are important. but a really useful tool. So same thing with rebar. I can update, say I'm in a seismic region, I need more rebar on my walls. I can update these factors, or I can plug in, say I know I'm getting rebar from a electric arc furnace, EAF process, and it's more efficient. I can change that. And all of these result in rerunning the takeoffs in a new takeoff here. And once I feel comfortable about all the values that I plugged into my program, I can download the data and export as a CSV. And I found this really useful to, you know, if you're comparing multiple iterations, design iterations, you can post-process and create different plots, or just use these CSVs to reference, because Beacon does not in the program save your analysis. So important to export what when you're done. And let's see, one last comment I think is important. So we talked about that A1 through A3 when considering LCA scope. You'll often, you know, I think you really want to also think about transportation, and particularly for construction, material inefficiency, so waste products. You can add factors for those products as well here. Say I have rebar, I know there's going to be an extra 10%, so I would adjust the multiplier here of scrap, and say for concrete. Or for steel, I also know there's something for my connections, say it's 10% as well. You can add that to your analysis to better incorporate that piece of the LCA. And again, we're focusing on that upfront, cradle to gate, cradle to site, because we know those emissions are going to be released sooner than the other like end of life emissions. It's more known, and as a starting point to assess your project, this is a quick and easy tool to kind of let you run through scenarios, bound problems, and get a sense early on in the design, what impact does my structural system selection, what impact does my material selection play on my overall embodied carbon. Okay, so there's a question in the chat from Anthony. Hi, Anthony, how you doing? What's the key difference between Beacon and Tally, or with EC3 and BIM 360? Is it primarily that it is open source, differences with underlying database? So this gets into the conversation about scope. I think, I'm actually fairly confident that Tally does include more in their scope. You can include like, what is scope D, or you can include like sequestration from timber elements. I would say Beacon is closer to EC3 in the sense that it's more, it takes those EPDs and multiplies by the material quantity. And yes, I think the other major difference between Tally and Beacon is free and open source. Hopefully that answers the question. And then I think, Renee, if you can actually unmute, and we can have conversation or any follow-up as well.
Everybody's unmuted.
Great. Anthony, did I answer your question? Was that sufficient?
Yeah, no, that's great. Thanks.
Yeah. Yeah, I mean, I think there are a lot of tools out there. And some tools that are, obviously more robust than Beacon, that can take that full life cycle analysis study. Really what Beacon is intended to do is be sort of kind of a break down the barriers to entry for structural engineers and provide something that is, quick, easy to understand, and can provide some insight on the onset of a project when you're doing these concept studies and when it's kind of the most impactful to make those design decisions.
Yeah, that's great. Actually, do you guys have ways of modeling different design options as well? Like when you're evaluating different structural options at the early stage, like, or would you kind of need to create different Revit models?
Yeah, you have to create different Revit models. But really, what I've done in the past is like, so often you're always comparing like concrete to steel, so the concrete and steel models will be separate, or if you have like a hybrid option that studies steel and timber, or concrete and timber, those would be separate models, right? But you can also bound the problem, like when you're looking at concrete and studying, say I look at EC3 and I have my upper bound and lower bound here for kind of reasonable values. I can do a takeoff, really this export tool I found most useful for comparing different studies. Is then you have all that data and you can post-process and create any plots that you want to look at different options. So heavy emphasis on the download tool for comparison and kind of encouraging bracketing of problems and trying to find, you can't get too specific, right? Because there are a lot of unknowns in the LCA analysis, but you want to understand, okay, is my option to use mass timber a order of magnitude more than or less embodied carbon than or a significant percentage than other schemes, right?
Yeah, makes total sense. Thanks.
Cool, thank you. And so just one last plug as we wrap up here. Thanks again, everyone, for taking the time to sit in on this discussion, and hopefully you learned something. Hopefully it was useful. I'm personally really excited about it and happy to answer any questions or give personal demos. Please reach out to me. I'll type my name in the chat one last time. And then I'm also really excited about this SE 2050 program that you may have heard about, that's similar to AIA 2030 for structural engineers and focusing on embodied carbon. Highly recommend people go to se2050.org, sign up for the email updates. The program is going to roll out in November. Also, highly recommend checking out the CLF website and getting engaged if you can with a local CLF hub. If there are any Los Angeles folks, please join the LA CLF hub, and we got really great discussions monthly, just all around good folks and a good community to get connected up with relating to embodied carbon. So with that, it's 3:15, and I'm sure there are more presentations coming, so I hope everyone enjoyed. And again, if any, please reach out if you have any more questions. Otherwise, thank you and enjoy the rest of your day.